In this video, I will be discussing one of the 4 types of prokaryotic gene regulation. I will be using a non-biological representation to illustrate the process in a more accessible way. This image shows the different types of gene regulation, but we will be focusing most specifically on positive inducible control. Before we get into this type of regulation, let's briefly go over the operon. Operons are a sequence of structural genes after a single promoter, which is the start of transcription where RNA polymerase binds. This is followed by an operator, where regulatory proteins bind and either activate or repress transcription. The structural genes that follow the operator are the genes that are being transcribed. These 2 words, positive and inducible, let you know what is happening to transcription. In prokaryotic gene regulation, positive and negative tells you what happens to transcription in the presence of a regulatory protein. When an activator protein is bound to the DNA, transcription is activated, and this is known as positive control. The place the protein is bound to is known as the activator binding site. The second word, inducible, lets you know what happens to transcription in the presence of a small molecule known as an effector. In the case of inducible control, transcription is turned on in the presence of the small molecule. The small molecule binds to the regulatory protein and activates it so it is able to function properly and bind to the activator binding site. When you put these 2 words together, positive inducible means that transcription is activated when an activator protein is bound to the DNA and it is turned on in the presence of a small molecule. If we go back to our starting image, you can see that the activator gene makes an activator protein, but this protein is inactive and cannot bind to the promoter region without the effector. When the effector molecule binds to the protein can then bind to the promoter region and it allows transcription to begin. For a non-biological example, imagine you want to make some tea. The tea bag steeping represents transcription in this scenario, which is the end goal. In order to make tea, you need 2 things, water and a kettle. In this case, the water would be like the activator protein, because that is what activates the tea bag to let it steep. But in order for the tea to actually steep and become drinkable, it needs to be placed in hot water. The kettle acts as the effector, because it is what activates the water by heating it up, which ultimately allows the tea bag to steep and become drinkable. Without the water, the kettle does not do anything. Without the kettle, the water remains cold or unactivated and the tea bag never becomes transcribed into drinkable tea. This shows you how both the activator and the effector are necessary for this process to occur. Similarly, the activator protein cannot activate the process of DNA transcription without it first being activated by the small molecule.